Hey guys, in today's video, I'm going to be solving this FRQ problem from the AP Comp Sci A past release test questions from College Board. There are more questions here, so if you guys want to see the link, I'll put in the description. So I'm just going to pick a random question here, and I'm already here, so I'll just go with number 2. Uh, Basically, by the way, for the FRQ section, they have the rules and times at the top, so. The MCQ section will come beforehand. This is why they named it section 2. And you get an hour and a half to solve 4 questions. But it's definitely not going to be like 4 questions, the bare minimum, because each question has several parts to it. So for question number 1, for example, we can say it has an A part and uh, and a B part. So those are already 2 parts that you need to write by hand. And question 2 has section 2 is just the one part, but section 3 will probably have an A and B. Yeah, so it's definitely several questions. So I hope this video will help you complete some certain questions faster. So we're going to do question number 2, which only has one part. And okay, so let's just start. The class single table represents a table at a restaurant. So it just created the class, and it's given us some stuff here. Let's quickly go through this. So this is obviously a method that'll just return the number of seats of the table. The value is always greater than or equal to 4, and it'll return an int, and it won't take any parameters. Also, this is very common. It won't show you the implementation. You should just assume that the method works correctly. Uh, this will return the height of the table in centimeters. It returns an int. The method's called getHeight, and again, it doesn't take any parameters. 1 second. Okay. Uh, and then this method will return the quality of view from the table. Instead of returning an int, this method will return a double, and it's called getViewQuality. This method is void, and it will just be more of a setter method than a getter method. This will take in a double value, and they will just set the view quality manually. And it says here there may be instance variables construction methods that are not shown. Okay. At the restaurant, customers consider tables that are composed of 2 single tables pushed together. You will write a class CombinedTable to represent the combining 2 single table objects based on the following rules and examples that in the chart follows. So here are the following rules. A combined table can see a number of customers that is 2 fewer than the total number of seats in its 2 single table objects to account for seats lost when the tables are pushed together. Let's say one of your single table objects have 5 seats and another one has 6. When you combine the 2 tables, you will technically have 11 seats in total, but because we need to account for the seats lost, we have to subtract 2. So in total, our combined table will have 9 seats. A combined table has a desirability that depends on the views and heights of the 2 single tables. If the 2 single tables of a combined table object are the same height, the desirability of the combined table object is the average of the view qualities of the 2 single tables. Meaning, if we call the getHeight method from both of our single table objects, and they're both equal to each other, we just have to get the average of the view qualities, which we can access from this method, getViewQuality, and we can just average them out, and that'll be our desirability for our combined table. However, this is for the other test case. If the 2 single tables of a combined table object are not the same height, the desirability of the combined table object is 10 units less than the average of the view qualities of 2 single tables. Basically, if one of our single tables came out to be maybe 40 centimeters, one of their heights, and then the other one was maybe 50 centimeters, we would first average those two out. So the average of 40 and 50 is 45, and then we would subtract 10, so then 35. So then the desirability of this certain combined table would just be 35.0, I guess, because it returns a double. And then here's like a little table. Remember, this code is just referring to the table down below. All right, so assume single table objects T1, T2, and T3 have been created as follows. So it's very important here you look at this first statement, usually the first statement, because it'll have the code that'll tell you what you need to have in your constructor. So, as you can see over here, I've already written the code, but I'll go through it step by step. I have the single table class open here, but it's basically just the same one as College Board. I just put it here so that this Java file could still compile. So it seems here it takes T1 and T2 as a parameter, and T1 and T2 are both single table objects. So the first thing I do here is I create two private instance variables that are both a single table object. So I just set single table T1 and single table T2. And then I created my constructor. Public combined table takes in my two single table variables and just sets them equal to that. Then you have to create a method called canSeat that takes an integer and returns a boolean because this is the value returned. And then, so you go over here, you have to go to canSeat. It's a public, you always write public on the AP exam unless stated otherwise. You return a boolean, it's named canSeat and it takes in an int. I just named mine A for this example. So what I did first is I created an int that I called n1, and that would be equal to my first single table's get num seats, which was written over here, and get num seats will return the number of seats at this table. And I did the same thing for the other table. And basically, all I have to do is figure out how many tables would be at the combined table. So like it said, we have to add both of them up and then subtract 2 to account for the missing chairs lost in the combination of the tables. And then all I said is if C is greater than or equal to A, because the A in this scenario is like what they're trying to check if they can seat this many people. So in the question example over here, they're trying to see if they can seat 9 people. So if we go over here, if C is greater than or equal to A, return true, else return false. Obviously, it's greater than or equal to because if you have the same number of seats, every person gets a chair. And so let's look here. T1 has 4 seats and T2 has 8 seats, meaning a total of 12 seats, but then you have to subtract 2, so you only have 10 seats in total. So then you can seat 9 people because you have 10 seats, but you cannot seat 11 people. That's why the 9 returns true and the 11 returns false. Next, you have to write a method called getDesirability. It doesn't take in any parameters, but it should return a double. So over here, you have to go here, public double and get desirability, no parameters. And then from here, as stated from above over here, if you scroll all the way up, the desirability depends on the views and heights of the two single tables. If the two single tables are of the same height, the desirability is the average of the view qualities of the two single tables. So first, let's start off by writing an if and else statement. For our if statement, I will call the method getHeight, which over here will return the height of the table in centimeters. We do t1.getHeight is equal to t2.getHeight, and if this is true, we want to return the average. So all I did is put this in parentheses, and then I divided it by 2, and that should work. And this should return a double automatically. I don't think you need. Yes, you would have to typecast actually. I made a mistake there. So you would over here, you should probably write double like that. Yes, this is better because over here, get height will return a int. So I think it's better to put double here. And okay, for the else statement, I created an integer called b, and all I did is I said that if because and our else condition is just basically saying, the heights of the two single tables are not the same. So this is our second test case. So now we're going to say t1.getHeight plus t2.getHeight divided by 2, which is what we did up here exactly. But now we just have to return that minus 10. And if we go down here to the table, there might be an example. Okay, so they created a new combined table object. They passed T2 and T3 to this time. So T2 has 8 seats, a height of 74, and T3 has 12 seats and a height of 76. So, get desirability. Uh, mhm. Oh wait. Oh wait. We don't have to put double over here. I forgot because this should actually be T1 dot get. This should be T1 dot get view quality actually. Uh, yeah, this should be T1 dot get view quality. And this should be T1 dot get view quality as well. So there's no need to put a double. And then I would do the same thing here, dot get view quality and dot get view quality. And then this should automatically create a double for you. So I'll just make B a double. And yes, this should work. So thank you guys for watching. There are more problems over here. I will upload this code to my GitHub in case you guys want to see. Uh, I'll upload both classes just in case you want to download it. But this class I haven't really added anything, so you guys can go ahead and edit it. And yeah, so that's all I have. Thanks for watching.